Okay, this is an example of how to go through these 5 apportionment methods. I suggest you follow along, and you should probably pause the video to go get your own blank piece of paper in order to do this. Apologies if the video is a little blurry. I have attempted to make it as focused as possible, so thank you for your patience. Okay, so we're going to start off with these populations. Again, you might have done different populations at a different time, but these are the ones for the example. We have 451, 350, and 199. Those total up to 1,000. And then we're going to label big, medium, or small. This one's the biggest. This one's medium, and that one's small. Okay. All right. So I'm going to come back to the Hamilton method last. So we're going to start off by doing some divisor method stuff. For this example, we are going to have 8 representatives. So our N is 8. To find our ideal quota, we take the total population, which is 1,000, and divide it by the total representatives or seats, which is 8. 1,000 divided by 8. When we divide 1,000 by 8, we get 125. That's our ideal quota. So the first piece of work we're going to do is I'm going to copy down these populations. The first thing we're going to do is divide them all by our ideal quota, which again was 125. I'm going to grab my calculator in order to do that. Here comes my calculator. Here it is. Okay. Alrighty, cool. So 451 divided by 125. That gives me 3.608, just copying right off my calculator. Next, I'm going to do 350 divided by 125 because that's my ideal quota. That gives me 2.8. And now I'm going to do 199 divided by 125. Whoops. Again, that was 199 divided by 125. And that gives me 1.592. Okay. So now I am going to attempt to use these different rounding methods here. So I'm going to start with Webster. Webster just rounds normally. So this would normally round to 4 because the 6 is bigger than 5. 2.8 rounds to 3, again, because the 8 is bigger than 5. 1.59 rounds to 2. That gives us a total of 4 plus 3 plus 2, which is 9, which is a little bit annoying because our N was 8, and we wanted it to be 8, so we're going to have to fix our quota. In order to do Huntington Hill, I'm going to need to first find my geometric mean of the 2 numbers that this is between. So 3.6 is between 3 and 4. So I want to know what is the square root of 3 times 4. In other words, what is the square root of 12? Okay, my calculator tells me that it is 3.464. Okay, great. I also need to know the geometric mean of whatever 2 numbers 2.8 is between. 2.8 is between 2 and 3. 2 times 3 is 6. And the square root of 6 is 2.4495 if we round to 4 decimal places. Okay. All right. And then also down here we have 1.59. That exists between 1 and 2. 1 times 2 is 2. And the square root of 2 is 1.4142. Okay, so the reason that was important is because in order to figure out Huntington Hill, HH, we double check. Is this number bigger or smaller than this? This number is bigger than this, so it rounds up to 4. I'm going to put a line here just to keep track of my work. Okay, this number, 2.8, is bigger than this number, so it rounds up to 3. And this number is bigger than this number, so it rounds up to 2. Ah, darn it. That adds up to 9, and we wanted it to add up to 8. Okay, while I'm here, let's do Jefferson. Jefferson rounds down. Rounding down this number, we get 3. Rounding down this number, we get 2. Rounding down this number, we get 1. That is a total of 6. We wanted 8. Okay, we're definitely going to have to try out some other quotas. Adams says to round up. That rounds up to 4. That rounds up to 3. This rounds up to 2. That gives me 9. Darn it, darn it. None of them were 8, so we're going to have to fix our quota. Okay, the next quota I'm going to try. The first quota was 125. I'm going to try 110. I'm going to move this up so we can see. Okay, new quota. We're going to do 110. Here are our 3 numbers. We're dividing them all by 110. And let's see what happens when we do. Okay, so 451 divided by 110. 350 divided by 110. And 199 divided by 110. Okay, the first one was 4.1. The second one was 3.18. And this one was 1.8. And if I rounded, 81. Okay. All right. So let's take a look. So for Webster, W, we would round these normally. We would get 4, 3, 2. That's 9. Okay. Huntington Hill, 4.1 is definitely, oh, hold on. We have to do something different now. We have to find the geo mean between 4 and 5. So let's just take a quick detour to find what the square root of 4 times 5 is. The reason we're doing that is because 4.1 on the number line is between 4 and 5. So what is the square root of 20? It is 4.472. 4.472. Okay, and that number 4.1 is definitely smaller than 4.472, so it would stay a 4. It would not get to round up to 5. We know from before that the geometric mean of 3 and 4 is this number, 3.464, and that is bigger than this, so this rounds down to 3. We know from before 1.81, the geometric mean of 1 and 2 is 1.4142. This number is bigger than that, so that's a 2. So that's still a 9. Darn it. Okay. All right, let's see if we're in luck with Jefferson. Jefferson says to round down. 4, 3, 1. 4 plus 3 plus 1 is 8. Yay! Okay, so we know that the Jefferson quota was 110. Great. So that means that on my answer part, I can go to the Jefferson column and I can write 4, 3, 1. And I can say that the quota I used was 110. Okay, cool. So far we used 125 as a quota. Then we tried 110 as a quota. The next one I'm going to try is I'm going to try to go in the opposite direction. Maybe I can get atoms, and I'm going to try 140. So I'm going to flip my paper over. Feel free to pause the video at any time. Flip my paper over. Again, those populations were 4, 5, 1, 3, 5, 0, and 199. And the next quota that I'm going to be trying is 140. So I'm going to be dividing these by 140. Okay, let's do it. All right, so we have 451 divided by 140. Enter. And that gave me 3.221. We're going to do 350 divided by 140. And that gave me 2.5. We're going to do 199 divided by 140. And that gave me 1.4214. Okay, great. Now, I got Jefferson. Let's try Webster. So Webster would round normally. This would round to 3. This would round to 3. This would round to 1. That's a total of 7. So close. We want 8, though. Let's do our geometric means really quick. We have some of them already. We know the geometric mean between 3 and 4 is, we said it was 3.464. 3.464. Okay. We know the geometric mean between 2 and 3 was 2.4495. 2.4495. And we know the geometric mean between 1 and 2 was 1.4142. 1.4142. Okay, so for Huntington Hill, is this number bigger than this? No, so it stays a 3. Is this number bigger than this? Yes, so it gets to be 3. Is this number bigger than this? Yes, it is bigger, so this gets to be a 2, which means we got 8. So exciting. So Huntington Hill, we found our quota for Huntington Hill. It was 140, and we got 332. So Huntington Hill, 140 was the quota we used. 332. Okay, cool. We're doing great. Let's see if Jefferson or Adams works for us here. Jefferson says round down. That's 321. 321 is 6. That's not right. Adams says round up. That's 432. 432 gives us 9. That is not right. Okay. No sweat. So far, we've tried a lot of good things. The next thing we're going to try is 130. We're going to divide everything by 130. And we already have our answer for Jefferson and our answer for Huntington Hill, so we don't even need to try those anymore. We're going for Adams and Webster only. Okay, let's try it. Here are our numbers again. Let's grab that calculator. Okay, 541 divided by 130 gives me 3.469. 350 divided by 140. Oh, I'm sorry, my bad. 350 divided by 130 gives me 2.692. Okay, and 199 divided by 130 gives me 1.5307. Okay, cool. All right, we're only caring about Adams and Webster because we found the other two answers already. Webster rounds normally. This rounds to 3. This rounds to 3. This rounds to 2. Oh, we did it. Woo! Okay, we've got Webster. That was a quota of 130, and it was 332. Webster, 332, quota of 130. Okay, cool. Let's check Adams really quick. Adams says round up. That would be a 4, a 3, and a 2. 4 plus 3 plus 2 is 9. Oh, darn it. Okay, we're so close, though. So the only one left to try is for Adams. Let's try 160. Here we go. Okay, 541 divided by 160 gives me 2.818. 350 divided by 160 gives me 2.1875. Okay, and 199 divided by 160 gives me 1.24375. Okay, Adams says to round up. That's 3. That's 3. That's 2. Yay, finally. Okay, so Adams was 332, quota of 160. 332, quota used was 160. Okay, great. Now, as I mentioned at the beginning, we're going to do Hamilton last because it's not a divisor method. It's a different method. So here we go with Hamilton. Again, this is a totally new method. Hamilton. Here are our populations. Okay, with Hamilton, the first thing you want to do, you find the total, which we know is 1,000. Then we find the percent. To find the percent, you simply do the population of the state divided by the total, like so. You can put these in the calculator if you want. Here are the percents. Step 2 is you take the percent and you multiply it by the number of representatives. In our case, that number is 8. Okay, so here we go. All right, I'm going to write these answers here. 3.608, 2.8, 1.592. Okay, now Hamilton says that you want to take the integer part, so just the number part in front of the decimal, and add them up. 3 plus 2 plus 1 is 6. We know that our n was 8. We have 2 representatives left to give away. So now we look at our remainders. Remainders are the places after the decimal. The first remainder is 0.608. The second remainder is 0.8. It's helpful to put zeros here as placeholders so that you can more easily compare these and give them all 3 numbers. And then the last one was 0.592. The biggest one of these 3 numbers, ignore this part. The biggest number is the 800. So we're going to put a +1 here. Okay. We have 2 to give away because there's 6 and we want 8. The second biggest number is the 608. So put a +1 here. Then we take our numbers from earlier, our 3, our 2, and our 1, and write them here. Final answer, 3 plus 1 is 4. 2 plus 1 is 3. 1 plus nothing is still 1. We now have a correct total of 8. So Hamilton was 431 with a total of 8. 431. That is the work that you will be doing. I strongly encourage you while you're studying to grab yourself or just make yourself on paper a blank of this, either with these numbers if you want to follow along or with your very own numbers, and go through this process. I would do it until you feel comfortable with it so that you know you can ace the test. And remember, you can bring these notes with you to the test. Okay, so definitely make sure to do that. Have a lovely day. Feel free to watch this video as much as you need to.